The last question we have to answer is how we're going to select the proper statistical test. The way we're going to select the proper statistical test is by first cueing in the information presented on your question stem what is the kind of data that is being used in the research study. The key to which statistical test is what kind of data we have presented. See, the world around us is not made up of numbers. The world around us is made up of things, and we have to apply numbers to those things in order to convert it into a form we can do our statistics on. There are four basic types of scales we talk about classically: nominal, also called categorical scale, ordinal scale, interval scale, and ratio scale. But having listed those, let me do as I always do and focus you on what's most important for your Step 2 CK exam. I need you to focus on only two of these four. I need you to focus on nominal and interval data. Nominal data is simply data where we have things in groups and clusters and categories. You say the things are classified. That's nominal data. Biological classification is nominal data. Animal, vegetable, mineral. That's basic nominal data. What you know is what box things are in. That's nominal data. The most commonly used nominal variable is, of course, gender, male and female. If you're one, you're not the other. That's the way we deal with these nominal classifications. Nominal data is simple, but it can convey important information. I mean, consider, I give you information about whether your patient is dead or alive, and that's, although a very simple distinction, very important information to be conveyed. Interval data, by contrast, is when we measure things using measuring devices graded in equal intervals. Interval data tells you not simply what category you're in, but instead how much of some quality you have. Interval data is data for which you can get a mean and a standard deviation. Interval data lets you get numbers, deal with the numbers, blend them together, and do the kind of mathematical manipulations we usually think about. When you think about measurement, just that word, you're probably thinking about interval level data. You have to be able to get a mean and a standard deviation for interval level data. So for example, height is at least an interval level variable. I can talk about the average height in the room. Weight is at least an interval level variable. I can talk about the average weight in the room or the standard deviation of the weights in the room. Consider, what's the mean of gender? Interesting philosophical question, don't you think? And there are people in San Francisco who, even as we speak, are trying to figure this one out, but we can't really do the calculation because gender is nominal data. I can't really generate that mean and standard deviation as for interval data. When you're saying what something is, it's nominal data. When you're saying how much of some quality you have, that's interval data. Why are nominal and interval data important? Because this is your first set of keys to determine which statistical test we should be running. Once you determine which statistical test you should be running, you can then have a simple second set of keys that guide you to pick the right statistical test. We have on this next table the common statistical tests you might have to choose among. But as always, I want to focus you on the most important, the top three here: Pearson correlation, chi-square, or t-test. The way you're going to decide which one of these statistical tests you should choose is basically which kind of data you have. So just reading from the table, if you have all interval data, the right statistical test is a Pearson correlation. If you have all nominal data, the right statistical test is a chi-square. If you have interval and nominal data combined, the right statistical test is t-test. What is a Pearson correlation? Who cares? Just pick it when all you have is interval data. What is a chi-square? Doesn't matter. Just pick it when all you have is nominal data. How do I compute a t-test? Nobody cares. Just pick it when all you have is interval and nominal data combined. That's the drill. The hard part of this is putting the pieces together. You're not going to read the question and know the statistical test. You're going to, 1, read the question, 2, realize what kind of data you have, nominal, interval, or a combination, and then 3, based on that set of decisions, you can leap to the right answer here at the end. Let's try a couple oral examples to let you work through this simple process. I believe that there's a relationship between what you score in your Step 2 CK exam and how tall you are. what you score in your Step 2 CK exam and how tall you are. How would I find out if that's right or not? Well, let's see, how tall you are, that's interval level data. Your score in your Step 2 CK, that's interval level data as well. So I'd answer that question by doing a Pearson correlation, and that's the right answer. I've always thought that men were more likely to fail the Step 2 CK exam than women. I always thought that men were more likely to fail the Step 2 CK exam than women. How would I decide whether or not that's true? Well, let's see. Men versus women, that's nominal. Fail, that's pass versus fail, that's also nominal. Two nominal variables, the answer there is, of course, chi-squared. I've always thought that men had lower IQs than women. I always thought that men were going to have lower tested IQs than women. How would I answer that question? Well, let's see. Men versus women, that's nominal. IQ score, that's interval. I have one nominal, one interval. Therefore, the answer is going to be t-test. And notice the genius of this design. You don't have to know what these tests are. All you have to do is detect appropriately when to use them. That's the process. The keys are therefore simple. If all you have is interval data, you're going to pick Pearson correlation. If all you have is nominal data, you're going to pick chi-squared. If all you have is interval and nominal data combined, the right answer, of course, is t-test. That's the basics of what you need to know to select the proper statistical test. I'm going to close out this section, however, just by doing a brief run through some qualities and characteristics you might want to know about some of these tests. This is, frankly, lower yield content, but I'm just going to cover it here with you for your general knowledge and just to handle some of the lighter questions that you might find on your exam. I first want to draw your attention to something we haven't talked about yet called meta-analysis. The idea of meta-analysis does show up in the exam, so you should probably know what we're talking about here. What is meta-analysis? It's simply the way we do a mathematically based literature review. We're trying to find a way to summarize all the existing literature, take all the different significances, p-values out there, combine them together in a logic-weighted way to get a single result, a single p-value. Prior to meta-analysis, we used to do literature reviews by, quote, subjective impression, unquote. I'd read the research and say, based on what I've read, I think the following is true. The problem is somebody else would read the same research and they'd come to a different conclusion. To stop these fights from happening, we have meta-analysis. And again, you don't have to know how to do this. Just know a meta-analysis is not how you're going to analyze your own data from your own research. It's how you're going to summarize, aggregate together all the research that was done in a given area to get a single conclusion. You also should notice that meta-analysis is a solution to one kind of bias we've talked about. It's a solution to confounding bias. Remember, the solution to confounding bias is do multiple studies. And meta-analysis is how I'm going to combine the results of all these multiple studies and get a single conclusion. Let's talk briefly about a Pearson correlation. A Pearson correlation coefficient ranges from a possible -1 to a possible +1. By the sheer mathematics, you can't have a Pearson correlation outside that range. How strong the correlation is depends on its distance from zero in an absolute value sense. So a negative correlation is not a weak relationship. A negative correlation is simply an inverse relationship. I'll demonstrate that in just a moment. Zero correlation means no relationship, or actually, more specifically, no linear relationship. Because the correlation coefficient doesn't look for any possible relationship, it only looks for the existence of a linear relationship. The stronger the number is in either the positive or the negative direction, the greater the evidence we have for a linear relationship. Most important here, though, is that correlation by itself does not mean causation. Just because two things rise and fall together doesn't mean one makes the other happen. There's a lot of often cited examples for this. Let me just cite a few of them here with you. We know there is a strong positive correlation between ministers' salaries and the price of whiskey. When ministers' salaries go up, there goes the price of whiskey. Happens every time. But it's not that ministers are going out and buying more whiskey. It's simply when the inflation rate goes up, so do ministers' salaries, and so do the price of whiskey. There's no direct connection there whatsoever. We know in communities all across the United States, there's a strong correlation between the amount of ice cream consumed and the number of people that drown in a given year. So So what's going on here? You're eating ice cream and going swimming like your mother told you not to? No, there's no causal connection at all here. It's simply in communities where a lot of people swim, where a lot of people eat ice cream, it tends to be hot, which facilitates both of those activities. It's important. When you're interpreting data presented on an exam question, if you see correlation data, it does not mean, and you will never pick A causes B. All we know is there's an association, not a direct causal connection. I'm going to draw your attention to these simple graphics presented in your syllabus. What we're showing you here is what different strength correlations look like when we plot them out, basic scatter plots. We have each of the interval variables on one of the axes, one on the horizontal and one on the vertical, and then we have scatter plots which show you the, convergence, what the value is on one axis relative to another axis. When you have a nice straight line, you have a strong correlation. When you have more of a cloud in the points, you have a weak correlation. So, at the top left-hand corner, that's a strong positive correlation. Positive because low with low and high with high, you have a line going the positive direction. Right below that, you have, of course, a strong negative correlation, an inverse relationship, where low goes with high and high goes with low. Right next to those, you have exemplars of what might be weak positive and weak negative correlations. You can see there's sort of a line there, but it's more of a cloud than a clearly defined line. Hence, the correlation would be down closer to 0. The very bottom, and on your slide over to the right-hand side, we have nothing but a cloud. There's no line whatsoever, and that's what you're going to see for a 0 correlation. I can get no line, so the correlation is going to be 0. Leaving correlation behind, let's go on to talk about t-test. T-test, you recall, is used when we have interval and nominal data together. But there's one more limitation. To do a t-test, you're limited to no more than 2 groups in your nominal variable. So, if I want to use a t-test to compare the heights of elephants and giraffes, I can do that. Because elephants and giraffes, those are 2 subgroups within that nominal variable of animal. If I want to use a t-test to compare the heights of elephants, giraffes, and ostriches, I cannot do that, because the t-test, remember, is limited to 2 groups. Another way we talk about a t-test is we're simply comparing the means of 2 different groups. Now, there's a different particular type of t-test I want you to be aware of, called a matched pairs t-test. A matched pairs t-test is simply a regular t-test, but one where we have a one-to-one linkage between the people or the objects in each of the 2 groups we're comparing. So if I were to compare, for example, the heights of men versus women, a standard t-test. Sometimes we call this a t-test, a pooled t-test, or a standard t-test. They all mean the same thing. If I wanted to, by contrast, compare the heights of husbands and wives, well, I can't use a standard t-test because, I have a one-to-one linkage. Every husband with one wife, every wife with one husband. Therefore, I run a so-called matched pairs t-test. The other time I run a matched pair t-test is when I have a before and after research design. If I give you a test at the beginning of the course to see how you are, I give you a test at the end of the course, you are linked in the beginning and the end of the course in very significant ways. That's not a standard t-test, that's a matched paired t-test to analyze that set of data. If I have more than 2 groups in my nominal variable, then I can't run a t-test. I instead run a one-way analysis of variance. If I have not one nominal variable and one interval variable, but 2 nominal variables and 1 interval variable, then I run a two-way analysis of variance. All way means here is how many nominal variables you got. If I have 1 nominal variable, 3, 4, 5 groups, it's a one-way analysis of variance. If I have 2 nominal variables and an interval variable, it's a two-way analysis of variance. Here's a graphic that shows you what it might look like when we're comparing data for a t-test, comparing the distribution of heights here of men versus women. The last of the statistical tests I want to talk to you about is the chi-square. Chi-square, you'll recall, is used when we have nothing but nominal data. Chi-square we often see applied to a 2x2 table, but that doesn't have to be the case. You can use a chi-square to analyze a 2x2 table, 2x3 table, 3x4 table, 8x6 table. As long as all you have is nominal groups, the right answer is still chi-squared. Make sure you follow what I'm talking about. Here we have a data table presented to you. This is a what by what design. Well, it's not a 3 by 3 design, it's a 2 by 2 design. You don't include the totals in the design. We have new drug versus placebo, 2, recovered versus not recovered, 2. This is a 2 by 2 design. And you would analyze this data with a chi-squared. And that, ladies and gentlemen, is statistics. No, I don't pretend that I've covered everything you'd ever want to know about biostatistics. It's not really my portfolio to do so. What I do hope is that I've given you the simple keys you need to answer statistics questions on your Step 2 CK exam. Spend some time becoming comfortable with these, and then it's crucial that you actually overcome your emotional response and actually try the question. If you have the content, but you just don't like the question, I fear that's going to defeat you in getting the right answer. So promise yourself and promise me you'll try every statistics question. Read it, think about what the key is that unlocks the question, unlock the question, and then move on to the next question in your exam.